Assalamu alaikum. Good afternoon, everyone. My name is Abdurrahman Khalemi. I'm a project engineer at Saudi Aramco project management team, working in Agile home ownership project. I have a bachelor degree in civil engineering from Liverpool John Moores University in the UK in 2014. And I've been working with the Saudi Aramco project management team for 5 years now in different projects at different phases. My presentation is going to be about building information modeling in a GR program. During this presentation, I'm going to share with you the information we think, based on our experience, that will be of most value to you, hoping that it will help you get started with implementing BIM for your project. So this is the outline of my presentation. First, I will give a brief introduction about BIM. Second is an overview about Agile home ownership program. In the third part, I'll be talking about the steps we took in implementing BIM for our project. Then I will share the challenges and lessons learned from our experience, and finally the conclusion. So, what is BIM? BIM is an intelligent model-based process for planning, design, construction, operating and maintaining physical structure. Or in other words, it's the process of making a digital 3D model out of building information. This model is to be used for all the project phases, from initiation to close out, maintenance and even demolition. It's very important to know that BIM is a process and it's not a software. It's a process that utilizes different softwares. There are many different dimensions of BIM, actually 7 dimensions. By dimension, it means the amount of information to be provided in the model. So 3D is the most familiar form of BIM, and it's where you get the most value compared to the normal design method. 4D is when you add the scheduling aspect to the design, sequencing and duration of activities. 5D is the cost information such as material and construction cost of each element. 6D is for the sustainability information related to energy consumption analysis that aims to reducing the energy consumption of the building. And the 7th dimension is related to facility management. It contains information such as equipment specifications, warranty information, maintenance schedule, expected lifespan, and other information that helps facility managers run the facility. Here I have listed some of the major benefits from using building information modeling. First is the better collaboration and communication across all the engineering disciplines and stakeholders from planning to completion. Also, early identification of work front, which allows the schedule to be compressed and optimized. The greater visibility allows construction sequencing to be validated, and also it creates a safer working environment. Real-time progress monitoring leads to more accurate reporting. And finally, the advanced work packages development deliver up to 33% cost reduction through improved labor cost productivity and reduced rework. Now I will introduce you to a Agile project where BIM was implemented. First of all, this is the project location. Agile community site is located in the Eastern Province in Tehran, along GCC Road and nearly 5 kilometers southwest of Saudi Aramco operations and north of Half Moon Bay. So this housing program is an important and iconic development both for Saudi Aramco and to the kingdom. It covers an overall area of 10 square kilometers of land divided into 2 increments. The project will construct approximately 8,600 housing units, including 1,250 apartments and 7,350 villas of different sizes, ranging from 350 meter squares to 900 meter squares. There are 30 schools, including special needs school and private schools, 2 interchanges and bridges, 2 fire stations and 1 police station, a grand mosque and provision for other mosques, as well as commercial and recreational facilities with all the required infrastructure and utilities. A project of this scale would normally require a huge engineering efforts to monitor and control every aspect of the design, and that is the reason BIM was introduced for initial site development packaging, to better control the cost and schedule and quality also with fewer resources. And as you know by now, BIM is beyond the 3D rendering model. It's a workflow or process to conduct project management. So at the time of initiating BIM for our project, we had 2 options: either to go with the available BIM initiation standards, or we capitalize on our existing standards. And since we have a well-established workflow, standards and procedure for executing projects, we decided to capitalize on our existing systems, which follows the typical life cycle of our projects that goes from initiation to closeout. Here I will explain the typical life cycle for the project in relation to BIM. So first is during the initiation phase of the project life cycle, we develop the business plan. The business case, we study all the possible alternatives in executing the project, which will meet the project objectives in order to select the most appropriate option. After that, we define all the scope elements and start developing a preliminary engineering design. So the deliverable at the end of the initiation phase is basically a well-defined scope of work with a 30% preliminary engineering design. So this scope of work is then used to obtain external engineering services for the project. However, when implementing BIM for any project and before approaching design, one of the most important documents to be developed is called the Employer Information Requirement, or the EIR. So this document sets out the information required by the client, the expected deliverables, and standards to be followed during the process of delivering the project. And since we already have a well-established, a well-defined scope of work, the preliminary engineering design to start with, and not to reinvent the wheel and start from scratch, we have embedded our BIM requirement in our existing scope of work. So this is the package BIM was implemented. It's increment to initial site development. It covers a total area of approximately 6 square kilometers, and the scope of this package is to develop the community infrastructure from underground utilities such as the potable water, stormwater, sewer and firewater networks, as well as irrigation lines, fiber optics, and electrical networks, and also the main road. So in addition to the typical scope for details, our EIR requirement for this package included a 3D BIM with clash detection and material takeoff. So we wanted to have a clash-free design. Once we have started the design work with the consultant, we started establishing BIM execution plan, which is another important document that is basically an agreement between us and the consultant in the way of conducting BIM. So our engineering scope of work refers to the BIM execution plan as a deliverable from the designer. So these are some selected pages from our BIM execution plan. On the left-hand side is the cover page showing the project information, and the other page is the table of content. Here we have specified our BIM requirement, the clash detection and resolution processes, our design review frequency, and the material takeoffs to be used for estimating purposes. The other page we have specified the file exchange format and the required software to be used. Also, we have included the BIM organization chart both from Aramco side and from the designer side. It is important to include the role of BIM manager or coordinator who is responsible for the model and the coordination between the different disciplines. So once we have started the design work with the consultant, we started establishing once the BIM execution plan is approved, the consultants continue developing the model as per the BIM execution plan until completion. The completed model was then submitted to us to be shared with the executing contractor during the build period for them to utilize it for construction. The following slides will explain to you the design process. So this is the master plan, which is the starting point for developing the BIM model. First, we have designed the roads to identify and align the underground utilities. After the roads, we started with the gravity deep utility, such as the storm water. Then the sewer water lines were developed, telecommunication and electrical networks. Then we have combined wet and dry utilities together. And finally, the roads were added to the model. So at this point, all services were combined and the model started generating clash detection information for resolution. As an example, these clash detection drawings were generated from the model during the design phase. The image on the right is more, on the left is more zoomed in, and it shows a physical clash between two underground services. These are other drawings extracted from the model. They show the different underground utilities details, such as manholes, catch basin, and service boxes locations, all in one drawing. And this model is for the portable water pump station. It shows all the design details from architectural, structural, and MEP. So currently we are at 10% construction progress for this package, and the contractor is utilizing the model to identify and resolve the clashes, generate shop drawings, and update the model with the as-built information as the activities proceed. Here is another example of the clash detection simulation during the execution phase. So this is an example I'm going to show you about a cross-section of a congested road intersection in increment 2, initial site development. It consists of sanitary water system, storm water system, main irrigation water lines, potable water lines, electrical and telecommunication networks, as well as water pump station and electrical substations. So taking an example from District 3A, here we can see an area that was modeled using BIM before applying the clash detection. So when we zoom in to that intersection over there, we can see the number of utility lines that are crossing the intersection and are clashing at different locations. And as you know by now, one of the key objectives from utilizing BIM during the construction is to evaluate the constructability and resolve the design clashes that have not been identified or resolved during the design phase. So this screenshot shows a clash report from the final design package prior to utilization of BIM in construction. So in the report, we can see a high number of clashes identified, which is not resolved. This is the same area after resolving the clashes. And this second screenshot, it shows the clash report after engaging BIM for construction to resolve the design clashes. The report shows a total number of 23 clashes identified for medium voltage cables with irrigation lines, where 3 are approved, which means not clashing, and 95 are resolved, finding alternative routes. At the end of the execution phase, the contractor will submit the updated model, reflecting the as-built conditions to the facility management or end user, for them to utilize it for operation and maintenance. Talking about the challenges, so whenever a new system or a process is introduced, there are always going to be challenges and difficulties at the beginning that you overcome as your experience and knowledge develop, and BIM was no exception. So here I have listed 2 of the major challenges we faced during our experience. First was finding BIM qualified design office and engineers who have experience and are familiar with executing infrastructure projects using BIM. This is mainly due to the low demand for BIM at that time. It was in 2017. And second is the utilization of BIM by the construction contractor, as most contractors find it challenging to utilize BIM efficiently with regards to the following point. First is the schedule integration to the model that, if used correctly, will support to better manage the work activities in terms of sequencing and duration, which will directly impact their cost. Also, the model contains accurate material specifications and quantities that can be extracted from it, which would reduce material quantifications effort done by the contractor during the bid period. And finally, the collaborative BIM feature could have been used by the contractor to manage his work better. As for the lesson learned, first is the client expectation regarding the outputs from BIM needs to be clearly defined in the employer information requirements to avoid any contractual interpretation or conflicts. Also, we have experienced that BIM required a long learning curve for stakeholders to understand its logic, so intensive courses and meetings were conducted to explain the way it works. Therefore, it is advised to plan to have BIM-related training before and during the project phases. Also, the integration of different software could lead to problems in the model, as different softwares have different limitations and their output might not integrate correctly in the model. So this point needs to be considered when developing the BIM execution plan. In conclusion, we can proudly say that we had a successful yet challenging experience using BIM. We have identified and resolved more than 2,000 clashes between underground services. Clashes like this in the design phase can be easily fixed with little or no schedule and cost impact, compared to a huge risk of affecting the schedule and cost if they were identified during construction. Also, our involved engineers are more knowledgeable and qualified to execute projects using BIM. Also, the end user will have the advantage of having the complete BIM model as part of the handing over deliverable, which will be a great asset as it contains all the project information for them to utilize it for operation and maintenance. Furthermore, our design was completed on time, and most importantly, we have estimated approximately 8% cost saving of the overall cost of the project, which is almost equivalent to the whole project cost. At the end, I hope I managed to deliver something of value to you, and I'd like to thank PMI for organizing such an important event. And thanks goes to you and for all the volunteers who contributed in this event.